Okay, so this should be Algebra 3, and we're working on Chapter 9, Section 1. Okay, and we just got done working on writing the six trigonomic functions. Okay, so we talked about sine, cosine, tangent, and all their inverses, right? So cosecant, secant, and cotangent. Now what we're going to be doing is going to be doing more than evaluating, okay? Before, what they did is they gave you all of the side lengths, or you just simply used Pythagorean's theorem to find the side lengths. Now it's going to get a little more complicated. So what you're going to have to do now is actually use some of these trig ratios to find the missing side. So let's look at this first example here. We got one up on the board, okay? And feel free to pause this or, um, you know, stop it or make it go as much as you want, okay? So Mrs. T is gonna be around to give you a hand if you have problems with anything, but I'm sure it should be just fine. Okay, so here we go. We're looking at this triangle, and right here we actually have a 28-degree angle, okay? So we have a 28-degree angle right there, and what we're going to be doing is we're trying to find what A and C is, okay? And the opposite angle, because when it says solve, right? Solve, that means find all. Find all of the solutions, okay? Not just one side, we're going to find everything. So here we go. So if we're looking at one, we might as well just start with this A, okay? Because that's one we can find. So we have the angle 28 degrees. We have the opposite side, because remember opposites right over here. So this is the opposite. This will be the adjacent because it's attached to it, adjacent right here. Here's your hypotenuse, okay? So there's your hypotenuse. All right, so you have your breakdown. So if I have 20 degrees, A is on the opposite side, and I have 15 right here, let's think about what do I need? What function do I want to use? The so, the ka, or the toa? You tell me. Exactly. That's exactly right. You want to use the tangent function, or the TOA. Why? Because we have the O and we have the A, so we're going to use tangent. Okay? So, what does that mean? That means tangent of our angle is 28 degrees, is going to be equal to our opposite, which I don't know what it is. I'll call it A, divided by our adjacent, which is 15. Okay, great. So this is going to be a piece of cake to solve for. All you need to do is simply multiply both sides by 15. So if I multiply this side by 15 and I multiply this side by 15, what will happen? These will cancel. So if those cancel, I'm left with A is equal to 15 times the tangent of 28 degrees. Okay? So what does that mean? That's just, remember, tangent of 28 degrees, that's just a number. Okay? That's just a number out there. So what we're going to do is we're just going to type that in our calculator. Okay, so to type in our calculator, what you're going to do is pull the calculator up, okay? Close this crap out. Get this out of here. Okay, so go to a regular tab on your main menu, okay? And I want 15, so 15, 5 times. Your trig functions are going to be under the trig functions button, which is right above the control. You see where I just hit it? It's highlighted. All your trig functions are in there. So I'm looking for tangent, tab over. There's tangent right there. Click on that. Tangent of 28 degrees. All right, and hit enter. Problem. All right, I got a length of negative 4.22. Okay, this is a common problem, okay? And this is why our calculators got to make sure they're set in degrees. Right now they're set in radians. Let me show you how to switch that out. So everybody grab your calculator. If you don't have it, pause it real quick. Go grab your calculator. Okay, now, so what we're going to do is we're going to hit documents. All right, then you're going to go down to number 7, settings. And you're going to go to number 2, document settings. All right, now, the second one down where it says angle. I don't want radians, I actually want degrees. So I'm going to switch it to degrees, and then I'm going to hit make default at the bottom. It says, yeah, yada, 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 sure. Okay, so now my calculator is actually set in degrees, and this is going to work much better. So let's see, if you highlight that, and let's try that again. 15 times the tangent of 28. There you go, 7.97, and that looks a whole lot better. So That's going to be our value for A, right? Yeah, for A. So 7.9, and we might as well just round, 7.98, okay? So A is going to be equal to 7.98, all right? So I have that value for A. So let's go back up to my triangle. All right, so this is 7.98. Um, I have B, and C would be nice to know, wouldn't it? Okay, so let's figure out what C is. So, all right, we're going to solve for C next. I'll do this in black. We'll kind of draw a little line there, okay? So this is solving for C here. ing, right? Solving, whatever. For C. Okay, so I'm gonna use that same 28-degree angle. I like that one. That's nice and easy. Okay, so if I have that 28-degree angle, and now I'm working with, let's use the adjacent. All right, so here we'll go. Let me highlight in like light blue. All right, so we're gonna use the adjacent, and then I'm gonna use the hypotenuse to find out what C is. So which function am I gonna use? The Sohcahtoa or the Toa? I have the A and the H. Which one has the A and the H? There's only one of those. That's cosine. So if I use cosine of my angle, which is 28 degrees, all right, that's going to be equal to adjacent, which is 15, where my B is, divided by C, which I don't know. Okay, so I'll solve for C. How do you solve for C? Well, if you're looking at this, the thing you don't like is you don't like this fraction. I can already see it on your face. I'm not even here, and I can see that you don't like the C on your face from the fraction. So let's get rid of it. Multiply both sides by C. Okay, these C's will cancel. You're going to be left with 15 equals C times cosine of 28 degrees. Now, remember, the goal here is to get this guy by itself. So what I'm going to do is I'm actually going to divide by cosine of 28 degrees. Don't be freaked out by that because cosine of 28 degrees is really just a number. Okay, so these are going to cancel. Isn't that nice? So we get C is equal to 15 divided by cosine of 28 degrees. All right, let's give that a shot in our calculator. All right, pull the calculator up. Not that. What do I want to pull up here? There we go, calculator. All right, so we're already in degrees. We already set it, made it our default, so we're good. So 15 divided by cosine of 28 degrees. So trig cosine 28 degrees and enter. Voila, 16.9, 16.99. So C is equal to 16.99. Okay, I realize I might have gone really fast, so hopefully you paused and kind of checked that out as I went. But there we go. So we have um, C, we have um, A, and defined the angle B. It will be the last thing we have left. So, all right, let's figure out what that's going to be. So angle B. All right, let me come up here. Okay, so angle B. That was the only thing we have left. That's right here. All right, let me go back in black. So how am I going to figure that out? Well, you don't even need any crazy trick here. Look at what it's going to add up to. This is a 90-degree angle. That's a 28-degree angle. And how many angles, or what's the total measure of a triangle? Yes, 180. Good. Okay. So what this is going to be to find B, all right, is going to be, all right, well, my numbers are 28 and 90, right? So I got 180 minus 90 minus 28. Okay, well, 180 minus 90 is 90. Okay, 90 minus 28. So that's going to be 2, makes it 30, so 62. 62 degrees is my angle for B. So B, and we usually denote it with a capital B. That kind of talks about angles, and a lowercase b usually talks about the actual side length. So there we go. We got B, we've got C, we've got A, we've got everything we need, and we're done. Okay. So I realize that's a lot of work, but once you get the hang of it, it's not too bad. So let's try one more practice problem together, and then I want you guys to try a couple on your own. Okay. So let's jump to this one right here. All right, you're looking at the diagram on the right, and we're going to use the same triangle on the right for um, all of our functions, okay, or all of the problems below. So they're going to give you some of this. So like in this first case, they're going to give me B is 45 and C is 5. So B is 45, C is 5. Now, we're going to solve for this. So if B, and that's a capital B, right? So that's going to be the angle right here is going to be a 45-degree angle. Oh, that's almost tricky. That's tricky, tricky. Yeah, and I'll explain why that's tricky, tricky here in a sec. Okay, so you're going to fill in for the rest. Even though this triangle looks like this, and you got to be careful, all right? Because what do you know about this angle A? What does that have to be? It has to be 45. Why? Because a 45, 45, 90, that's a very common triangle. Because 45, 45, and a 90 adds up to 180. So we found big A pretty easily, even though that's not what the picture would look like. The picture would not look like that, okay? The reason it does is because they're using just a general triangle to describe the rest of them. So capital A is going to be 45 degrees, piece of cake. Okay, B is 45, we knew that. C is going to be 90. I mean, that's not even, it's already there. So what I have to find is little a and little b. Okay? All right. So those are the two things I got to find. Now, if if I'm looking at this, I can kind of go about solving this any way I want. Now, so we're given that C is actually 5. So C is 5. So let's put a little 5 up there. If that's 5, I can go multiple ways here. I think I'm just going to take this angle right here, okay, and I'm going to use the sine function because that would be opposite over hypotenuse. Okay, so that's the sine function if you forget. So that means sine of my angle A, which is 45 degrees, is going to be equal to A divided by 5. Okay, so that's that so from Sohcahtoa, this S-O-H. So now to solve this, I'm going to multiply both sides by 5, and I'm going to get A is equal to, these 5's cancel, 5 times sine of 45 degrees. And I'm going to punch that in my calculator, figure out what that is. Not that button, this button. Okay, so here you go. 5 times sine of 45 degrees. Enter. 3.53. All right, so A is equal to 3.53. Okay? And that's the distance for A. So, all right, so little a, this guy right here, we'll put little b over there. So little a is going to be 3.53. Okay? Okay, so we found A, and now I'm going to look for B. Let's look for B. Yeah, because I need to find B. That's the last one I need left. So let's kind of take care of this. I'm going to look for this value right here. Excuse me. So if I'm using the same angle, all right, angle A, that means I'm going to use cosine because I have the hypotenuse, I have the adjacent, and I have the angle. So cosine of 45 degrees is going to be equal to B divided by 5 because that's the ka in cosine. Okay. So multiply both sides by 5 times 5 times 5. These 5's cancel. B equals 5 times the cosine of 45 degrees. So let's just take that in and figure out what that is. So 5 times cosine of 45 degrees. Close that off, hit enter. 5.53. Okay? So 5.53. So B is 5.53. Really, that should be 5.4, right? Because that was 5.535. So it should be 5.54, really. Okay. And so should that one. So 3.54. Okay. Now, isn't that convenient that both your side lengths are the same? And that makes sense because if this angle right here, okay, if that angle right there and this angle right here are the same, these side lengths must be the same. That's just a given. Okay? So yeah, it's a lot of work to do these problems, but that's kind of the bulk of what we're doing in this whole section. This is the main part. So this lesson might actually end up taking you a little bit more than one day, but that's perfectly fine. If it drags out, that's okay. So what I want you to do is try number six on your own using the same triangle. You might as well, I'll erase this for you so you can kind of see where you're at. Using that same triangle, I want you to use number six. So I'm actually going to take a little screenshot of this thing and send it down below. Oops, hold on. No, I don't want to do that. Shoot. Okay, it's all right. All right. Picture of that thing. Okay. All right. Let me get back to my desk real quick to get that thing to come back to the other page. Oh, okay. Cut, and then we'll come back here and we'll paste it right there. That's what I wanted to do. Sorry about that. Okay, so delete that page. Okay. Now, so this is the one I want you to try next. So, Mrs. T, if you don't mind pausing the video, give them a chance to try number six. You might as well let them try six, seven, and eight, depending on how well six goes. And then when you're ready, you can hit the pause or hit the play button again, and I'll come back and solve it for you so you can see how that one works. And we'll try a couple for homework too. Okay, so hopefully you tried number six. I'm coming back. You already tried number six on your own, and we'll see if you got the right answer, and then we'll do seven and eight too. So you should try those on your own as well. So, all right, let's come back to number six. Let's see how it goes. So if I'm looking at number six, okay, and I'm trying to solve this problem, and I'm given a couple things. I'm given that I'm here. Come on now. There we go. All right, I'm given that A is 32 degrees. So this is 32 degrees. Okay. And B is 10. So B right here is 10 degrees. Or not 10 degrees, but just 10, just straight up 10. Okay. And I'm going to try to find the remaining things. So I need angle B, angle C. I already have angle A. So angle B is well, angle C is easy. It's 90 degrees. I need to find little a, little c. These are the things I'm trying to find. Okay? So if I'm looking for big angle B, that's going to be a piece of cake because it's 32 plus 90, right? And then minus 180. So you can just punch that right in your calculator if you had to. So you can go 180 minus 90 minus 32. Bam, right there. So 58 degrees. So that tells me, and that's helpful because that kind of lets me do some different things. So if this is 58 degrees, okay, we're going to try to, we'll put the 58 here, 58 degrees, okay, and now I'm going to try to find little a, little c, and then we'll be good to go. So to find little a, what I'm going to do is I'm going to use the 32, all right, I'll use this guy, trying to find him, and I might as well use this 10 too. So what do I have? If you think about what we're looking at here, this is your opposite, or your OPP. This is your adjacent ADJ. This is your hypotenuse HYP. Okay? And we're going to fill in the gaps here. So if I'm looking, I have, here, let me highlight. If I'm using this angle, 32 degrees, and I'm trying to find A, so that's the opposite, and I'm using the adjacent, so I'm using O and A. Which one uses O and A from Sohcahtoa? So I don't remember. Oh, that's funny looking. Toa. Okay, so which one am I going to use? From the O and the A, that's going to be tangent. Tangent. Okay, so what does it tell me? It tells me tangent of 32 degrees is equal to A divided by 10. Okay, so if I multiply both sides by 10 to clear out this fraction, okay, we'll see, you're doing the same kind of steps over and over and over. Multiply this side by 10, I have to do this side. I got to balance this equation out. I don't want to leave it lopsided. So A equals 10 times the tangent of 32 degrees. Oops, yeah, 32 degrees, we're good. And then I'll have A. So, all right, that's easy enough. Just type it in your calculator. So 10 times tangent of 32 degrees. Enter. 6.24, 6.25. We'll just round it there. 6.25. Okay. So A is equal to 6.25. All right, 6.25. So A is done. Great. Fantastic. Now I'm going to move over to finding little c. So little c is the hypotenuse right here. Okay. And what I'm going to try to find, I'm going to use the same 32 degrees. I might as well. I'll use this 10 too because I like that better than a decimal. So I'm going to use the things circled in green. Okay. Things circled in green is what I'm working on to find little c. So I have adjacent right here and I have hypotenuse. Which one uses A and H? Ah, you got it. Cosine. Okay. All right. So if we're using cosine, let me get these guys out of here. You guys get out of there. Okay. So if we're using cosine, cosine of my angle that I'm using, which is 32 degrees, okay, is going to be equal to 10 divided by c, okay, because it's adjacent over hypotenuse. Now, to solve for c, I'm going to multiply both sides by c. So multiply by c, multiply by c. These are going to cancel. You get 10 equals c times cosine of 32 degrees. And now we're going to divide. We're going to divide both sides by cosine of 32 degrees. Cosine 32 degrees. These cancel. Isn't that nice? So we get c is equal to 10 divided by cosine of 32 degrees. All right, so let's figure out what that is. All right, so calculator. 10 divided by cosine 32 degrees. Enter. Bam, right there. Okay, so 11.79. Let's just call it 11.8. Okay, so C is equal to 11.8. So that's 11.8. So now I have all the sides of the triangle. So look at your triangle again. Like I got everything. I got angle, check. Angle, check. I already know that angle, check. 10, check. Opposite, which is little a, that's check. Got it. Hypotenuse, which is little c. Got it. Check. I got everything. I got everything I need. You need three angles, three sides. So angle, 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 side, side, side. And we're good to go. Okay? So that's number 6. Hopefully you got the same answer. If you didn't, that's okay. Figure out where you went wrong. Let's see if we can kind of correct it from there. Okay? So if you have enough time, let me see how far into the thing I am. 22 minutes in, so why don't you try 7 and 8? I think we have enough time to get through this. We should anyway. We'll try 7 and 8 and we'll go from there. So let me drop that same triangle on. Let's get this guy out of the way so you can see. I don't need you anymore. You get out of there. Okay, he's gone. All right, so let me bring this triangle back so you can kind of see what you're looking at. Paste. There's the triangle, same triangle. I'm gonna move 8 down there so we have a little more room. All right, so 8's there, 7's there. I want you to try these on your own, see how you do, okay? And if you do well with them, you're good. And if not, then, more practice. So here we go. Go ahead and try them on your own. Pause the video. Okay, now we're back. Hopefully we're back. All right, so if we're looking at this, we're going to fill in what we know. This angle is 71 degrees. So that's a 7. Bad 7, but it's a 7. Okay? C is going to be 20. All right, C is 20. All right, so that means this angle, no, this is a 90, obviously. So this other angle, 71 and 90 gives you 161. Oh, I need 180, so I need 19 more. So that's a 19-degree angle. So B is 19 degrees, okay? A and B is what I'm trying to find, and I'm good. Little a, little b. Okay, so little a, what do I want to use here? So little a, all right. Hold on, where did the 20 come from? That seems weird. Where did this 20 come from? I don't know where that came from. Oh, yeah, I do. Little 20 was that was C, so this is 20. All right, so I'm trying to find A. So let me get a little highlighter out here. I want to find him. I got him. All right, so I'm looking for the opposite. All right, so if this is my angle I'm using, the opposite's right there. Okay, and I'm trying to find what it is, and this is the hypotenuse. I'm given the hypotenuse. So if I have the hypotenuse, and you're looking at if you're looking for Sohcahtoa, jeez. If you're looking for Sohcahtoa, well, which one do you want to use? Think about it, because you have a hypotenuse and you have the opposite, so you're gonna want to use this guy, right? You have the hypotenuse, you have the opposite, you're gonna use sine. So sine of our angle, which is 71 degrees, is going to be equal to the opposite, which is A, right? Because I don't know it, over the hypotenuse, which is 20. Okay, great. So how do we solve this? We multiply both sides by 20 because we don't like this fraction. I don't like it. You don't like it. Nobody likes it. So multiply by it. All right, now he's gone. Now we're all happy. Okay, so A is equal to 20 times the sine of 71 degrees. And that's going to go directly into your calculator. So let's figure out what that is. Um, hmm, all right, so 20 times sine of 71 degrees. Bam, 18.9 equals 18.9. So that's 18.9. We got that figured out. That's great. So we have A. And now we're going to try to find B. All right, let me see here. Okay, good. All right, so B. So now we're looking for B, and B is right here, circled in black. And we have the hypotenuse still, which is C. So now we have the adjacent and the hypotenuse. So that you should be thinking, bam, cosine. Okay? So if I'm working that out, let me give myself a little more room. Cosine of my angle, which my angle in this case is going to be 71 degrees, okay, is equal to the adjacent, which I don't know. What do we want to call the adjacent again? The adjacent's B. B divided by the hypotenuse, which I do know, which is 20. Okay? So I'm just going to solve that. All right, so that's multiply both sides by 20. So these cancel. B equals 20 times the cosine of 71 degrees. Let's figure out what that is. 20 times cosine of 71 degrees. Enter. 6.5, 6.5, 6.5. So B is 6.5, and that's my final one I needed, 6.5. Now I got all three sides, all three angles, right? So here, let me show you where angles are. Highlighter. All right, so angle, angle, the last angle is 90, okay? And then sides, side, side, side. All right, so I just solved the triangle. Okay, so that's solving the triangle. All right, so let's try to squeeze one more in. I don't know if we'll have time or not, but you guys can kind of decide that on your own. All right, so we're going to try to squeeze one more in. Let me see what I can do here. All right, so B. All right, I need another one of those triangles, so I'm going to drop another one in here. Okay. Let's see here. Control. All right, there we go. Okay, so this is the last triangle we're going to try today before I give you a little homework to kind of trying to wrap that up. And I see I'm creeping up on half hour here, so I'm sure I'm running out of time. But let's see if we can squeeze it in. If not, come back to it tomorrow. No big deal. Okay, so angle B right here is 60 degrees. Okay. Now, side A is 7, so that equals 7. And, yeah, that's all we're given. All right, so we can find the last angle. How do we find the last angle? Good answer. Fantastic. Yes, you just subtract it from 180. So it's 180 minus 90 minus 60, which is going to leave you with a 30-degree angle for angle A. So angle A, 30 degrees, piece of cake. All right, so we have our 30, our 60, our 90. Super common triangle, and it should look familiar, hopefully. Okay. All right. So now solving some things here. We're given, if I'm going to use the 60, all right, so the opposite is, this is going to be opposite OPP. That's ADJ. This is HYP. Okay. And if I'm thinking about which one I want to use, well, let's solve for B first, okay? So we're looking for B. We have A. So we have the opposite and the adjacent. That's going to be tangent function because that's the TOA, okay? So tangent of my angle, which is 60 degrees, is going to be equal to B divided by 7. Yeah, so opposite over adjacent, that's what tangent says, all right? So to get b by itself, pretty easy, just multiply by 7 on both sides. So you're going to get b is equal to 7 times the tangent of 60 degrees. I'll just type that in the calculator. 7 times um, tangent of 60 degrees. There you go, 12.12. Perfect. So B is equal to 12.12. Okay? So this value is 12.12. Okay. Now, we're going to try to find C, and then we're all good to go. So really, you don't have to use trig at this point. I probably forgot to mention that before. You could just use Pythagorean's theorem here. But, you know, it's a little more accurate with the trig. Why don't you just stick with the trig? And it's probably actually easier than squaring, you know, decimals and stuff like that. So if we have little b is going to be 12.12. And we'll look for little c, and we're good to go. All right, so if I'm using the, let's use, what the heck, let's jump over to this 30-degree angle. So if you're looking at the 30-degree angle now, let me get a different color highlighter. We'll go in light blue, okay? So if we're looking at the 30-degree angle, and we use this 7, and we're trying to find C, what do I have? I have the opposite, right? And then I have the hypotenuse. So, you know what, I might have just confused you there. Let me back that up, because I just changed angles on you, which changes sides. So let's back that up. We'll stick with the 60, okay? All right. Forget I just said that. Rewind it. All right. So let me grab another highlighter. Let's go. Now, if you stick with the 60, okay, I have the adjacent and I have the hypotenuse. So let me do that in light blue. Hypotenuse, adjacent. Which one uses the adjacent and the hypotenuse? Good. Cosine. Very good. Or maybe not very good. It depends. I don't know. Okay, so cosine of 60 degrees is going to be equal to 7 over c, because I don't know what c is. So multiply both sides by c times c times c. So these cancel. 7's equal to c times cosine of 60 degrees. All right, so I want to get c by itself. How do I get c by itself? There's only one way of doing that. Divide by cosine of 60. On both sides, because I got to balance it. Yes, I must balance it. Okay, so they're canceled. Okay, now I'm left with C is equal to 7 over cosine 60 degrees. Okay, now, what does that mean? Well, let's figure it out. That's in the calculator. So, what do we got? 7 divided by cosine of 60 degrees. Enter. 14. Nice number. Okay. That's real nice. That's almost too nice. Is that right? Yeah, that's right. Yeah, it's just a really pretty number. It works out really nice. So it's 14. Okay. So you have all of your sides. You have all of your angles, right? So let's double check. You should have 3 angles, 3 sides. Let me get my highlighter out here. Okay, so we got angle, angle, and then there's the 90. And then we got sidewise, we got side, side, side. Okay? So I imagine there could be some confusion now. Hopefully you're helping out your other classmates, and I know Mrs. T can clarify some of this for you, but that's our next section within 9.1. Okay, so what I'm going to do is I'm going to give you some homework. You can kind of check these problems out. If we rolled over to the next class period, that's okay. Like I said, be flexible. But here's the homework problems I'd like you to try. They're the odd ones, so they're in the back of the book, okay? And I imagine this could take, it might take you a decent amount of time. So even if they need to wrap it up in class, you guys can kind of make that call, depending on how well or not well they're doing. If they're doing really well, just let them do it at home. If they're not doing so well, let's just do it in class the next day. You guys can take some time and go over it because this is the part I really, really want you to get down. Okay, so check those out. The answers are in the back of the book. Mrs. T also has a teacher's manual or a teacher's thing, so she has the answers too. But take your time, really go through these. I really want you to work these problems out, make sure you understand what you're doing, and we'll kind of go from there. So this should have been the first day that I was out, so I'm assuming this should be Monday if everything went as planned, but maybe not. Okay. So we'll call that we'll call that 9.1 part A, I guess. I guess that makes sense. Um, okay, good. If you have any questions or anything, you can just ask Mrs. T. She'll give you a hand. Okay. All right. Well, then we'll see you tomorrow or maybe the next day, depending on how you do with that homework. And yeah, good luck. Okay.